a little bit worried about quantum mechanics. I hadn't taken it, or I was about to take it the next semester, and I was asking around for questions or for book recommendations from other people, professors, other students, people who had taken the course, people who had taught the course quite a bit, things that they thought would be really good as a sort of pre-read to get into quantum mechanics. Anyway, the main meat of this is, I got a lot of book recommendations, and I was, of course, reading them, and they weren't particularly great. There was a huge amount of waste, in my opinion, of just stuff that I knew that wasn't helpful for me to go over again. And I don't really remember how I found it. It wasn't a recommendation, though, I can tell you that. I think I was Googling a question that I had from quantum mechanics. It's from some book I was reading. It might have been a history book, and like a book that went over the history of how quantum mechanics was derived and all this other stuff. What is wrong with my throat? Jesus Christ. But anyway, what was I talking about? So, anyway, I found this, I think Googling some type of question, and basically this book was what I was asking for. This book was an incredibly great primer. It was literally so great that when I was taking the actual quantum mechanics course, I kind of didn't read the main textbook, and I read this book instead, just because the main textbook, like, in my opinion, it had either more waste, as in things that weren't helpful for me to learn, or they would spend so long going over something that was just trivial, like completely unimportant to go over, or like it didn't treat things in a particularly decent way that I wanted to do. And anyway, after having gone through that a couple of times, and after having graduated and been in the workforce and having to read, I've sort of started to develop a somewhat of a theory of like knowledge gain, or maybe of specialty instead of knowledge gain. Not really sure what to call it. It's not like an academic theory or anything, so feel free to think of it however you want. But basically, how I think of it is knowledge is something that brings you so each time you gain new knowledge, you acquire a new identity. So knowledge is sort of an identity-based thing. So for example, let's say we have this identity thing of physicists, and then we also have this separate group, mathematicians here on the left. And physicists, of course, as you gain more knowledge than just the sort of base undergrad physics, you then acquire the newer identity, or the more specialized identity of quantum physicist, of QFT physicist, of particle physicist, or etc. Math, most people don't really know much about math, but the same thing is true there. You have, of course, analysis, group theory, category theory, topologists, this whole set of math. And the thing is, whenever you're talking to a more specialized group, the book recommendations that they give you to join their sort of identity, to acquire the identity, or to join the group, fundamentally will come from the base of that group. So each physicist will recommend a book from physics. So if you're wanting to be quantum, if you're wanting to acquire the identity of knowing quantum mechanics, then of course they recommend to you the physics books of quantum mechanics. They recommend to you Schroeder. They recommend to you Griffiths for E&M, the core books of physics. But if you've already got this other group here, like analysis, like if you have a lot of math-heavy knowledge, there is a way to do it that is more uncommon, where you can just jump over the base group physics and just go directly to like QFT or quantum. And in terms of actual academics, this does actually happen somewhat more frequently. Generally, it's in the shape of a course, or you'll have like mathematicians, and they'll be like, hey, I'm kind of curious about quantum field theory. I don't know much about physics, though. Then like a mathematical physicist or something like that will be like, it's fine. I can just make a quick 6-month course and bring you up to speed on QFT, because you don't need to know all of physics. Like, you don't need to know a lot of the I guess, more condensed mattery aspects of physics to be able to apply work to quantum field theory. But I mean, if you're wanting to gather the sort of full identity of physics, of course you do have to learn all of the individuals. So maybe this isn't particularly a great example, but I think programming is incredibly important to recognize this. So for example, let's say you're wanting to change languages from Java to C++ or something like that, and you are a Java graphics engineer. You've worked in graphics and rendering, etc., like that. And you put on, hey guys, I'm a Java graphics engineer, and I'm wanting to learn C++. What are your book recommendations? Well, the thing is, book recommendations in this case are more likely to come from the sort of standard identity, the more general identity, to the more specialized. And people won't think of it as specialization of, oh, graphics engineer Java to graphics engineer C++. Depending upon who you talk to. If you go to like CPP reference or something like that, they tend to go C++, C++, graphics, C++, blah, and then Java graphics, like etc. like that. So when they recommend stuff to you to learn another language, they'll recommend you to go all the way down to Hello World, helloworld.h, helloworld.cpp. I actually don't know why you would need a header for Hello World. No idea. but they'd recommend you'd start with Hello World, of course, then after that you make more complex software in C++ using some sort of simple application, just something 300 lines, I don't know, like a prime function finder or something like that. And then they'd recommend from that to then learning just some really standard graphics, maybe like SDL2, etc. like that. And then from that they're into, then you can learn Vulkan. But I mean, if you know graphics in Java and you're wanting to write graphics in C++, there's no, you don't have to do these first things. You can sort of skip over them, and if you just think a little bit more, I guess, you could jump directly from Java rendering to Vulkan rendering, just because the rendering pipelines are something you learn along the way of writing rendering code, and you don't really need to know too much about the whole Vulkan spec to be able to use Vulkan for simple rendering purposes if you're wanting to just learn C++ or same thing with OpenGL. In fact, I'd even say OpenGL you'd have to learn even less, because OpenGL tends to be more abstracted out. You need less control. I think you still have the option, especially if you're not doing something way too like a full game engine, and you're just doing some sort of simple graphics. Like OpenGL is way in excess for what you're wanting generally. But anyway, the main meat of this is sort of like that people, when they recommend books to you, they don't recommend books based on who you are generally. They tend to recommend books from, oh, I assume you're the more general person in this subcategory, and you're wanting to become more specialized. Anyway, that's more or less the theory. Here's a sort of motivating reason for, I think, why this happens. The motivating reason to me has to do with the history of how books were created. So, at first everything was just spoken. It was there. We didn't have anything to write things down. And so if you wanted to learn some sort of specialty, basically what you had to do was you just had to go up to somebody who was a specialist and talk to them directly and be like, hey, give me your knowledge or whatever. When we made books were, first off, incredibly expensive to write. Like, it takes a long time to write a book, and also incredibly expensive to produce. Like, you have to have, the entire printing press. You have to have a scribe or something to like etch into stone what it is that you're wanting to say. So it's a very big time commitment for every individual book that is created. So if you write a book for one person, that's a huge waste of time. You're wasting a huge amount of other people's time. You're wasting raw materials. You're wasting... So most of the time, whenever people would write a book, they always go, oh, assume you're talking to the most general person, and you want to bring them from the most general person up to whatever it is you're wanting to talk to. And I think nowadays, with the internet and how low cost it is to produce a book, it's still high cost to write a book. It's still high cost to acquire the knowledge to write a book, and then also high cost to condense your knowledge down into a book. But the high cost history stops people from writing books for these type of specialized people. And the end result is that if you're wanting to go from one really specialized identity to another really specialized identity, it's a huge amount of wasted learning. And I mean wasted learning. When I was coming from... so one of the things I had to learn from my job was I had to learn quite a bit about graphics, and I had to learn quite a bit around the Unreal Engine rendering pipeline. How it actually happened doesn't really matter too much, but I would read these textbooks on graphics, and like there would be 5 chapters dedicated to just math, and it would be like 5 chapters of dedicated math, and then they talk about these really generalized aspects of computer graphics, like, oh, here's how you print a triangle to the screen, here's how you like color things, blah blah blah. And then if you wanted to get another book which is far more specialized, rather than just assuming you know about graphics, or rather than just kind of stating, okay, this book assumes you know about the graphics pipeline, if you don't know about the graphics pipeline, here you can read this instead, they would always include the math section. Even if the later on things that you would be doing in the book were so difficult, there would be no way for you to not know vectors before you could start doing that. And it just sort of annoyed me. Like, I was reading like 6 textbooks on graphics, and like half of them, each of them was just a complete waste of time for me. Like, it just didn't help me whatsoever. Because there's just nothing to do there. They were just stating the same thing over and over and over. Ultimately, what that made me want to do was it made me want to bring to the front these books that I really enjoy, where they don't try and just write to the most average person. They try to write, okay, this is, like, I'm assuming you know a lot about this. If you don't know a lot about this, you're not a member of this group, so just go to a different path. And so what I created was I started creating an Obsidian document. This Obsidian document is just more or less the things that I read and trying to network which ones required other ones. More or less what I want to do is I wanted to map out the network, and then I wanted to find these books. The books that, you know, were for mathematicians, so if you read them as a mathematician, it would be far faster for learning whatever it was you wanted to learn than it would be if you tried to go through the full pathway. So again, as an example, let's say you're learning, you already know some programming. You know about algorithms. You know about some other stuff. I have no idea what it. And you know about TDD, okay? And you want to learn TDD in C++. Well, or you don't know about TDD. What you would do if you were doing this the more or less correct way, quote unquote, the way that most people would learn about TDD is, first off, you learn just TDD. You learn the aspects of TDD, how it works. You learn all this other stuff, and then you learn whatever language you want to learn. You learn C++. You learn how to do C++. You learn blah blah blah, and then all of this stuff has to be like a prerequisite knowledge. So you learn all of that, and then after learning TDD, C++, blah blah blah, you would then have to learn separately some whatever testing framework you're wanting to learn, like Google Test or something like that. But like, if you have knowledge of testing, but just on C++, you can skip the whole TDD step, just go straight to Google Test and learn TDD while doing Google Test. of course, the more short you make this, the easier it is to try to be like, oh, well, it's not too much work to try and do something like that. But there are some pathways that are incredibly, like, thick, that this is highly appropriate to, especially in programming. Like, if you're wanting to learn security programming, or if you're wanting to learn something like reverse engineering, and you already know a lot about I don't know, C++ or something like that, there are much faster ways to learn reverse engineering before trying to learn assembly, or there are much faster ways to sort of drop from one specialty to another specialty. Now, of course, this isn't like done. It's going to take me a while to finish this, mostly just because I've been really busy the past few days. The second thing is because the books that I read over whatever period I was reading them is currently around 8 gigs. That's a huge fucking amount of books. I did not realize I read that much when I decided I wanted to start this. But I mean, I already started it, so I'll just slowly build it up over time as I go throughout whatever it is I'm doing. But, you know, I guess Linux would actually be a really good example of that. Like, if you're wanting to learn some aspect of coding and you already know a lot about Linux, there are just much easier ways to learn it by just directly using Linux than it is to try and like route through some sort of standard pathway, because Linux just has a huge amount of things available to it, and also it's incredibly easy to make changes to do whatever it is you're wanting to do. Like right now I'm using NixOS, and NixOS is great. I've used Arc since, or Arch, people call it Arch. I always called it Arc, but I never heard people talking about it. I just always saw the word. Why is it D? I don't know. But I've used Arc since probably, middle school or something like that. But I've recently swapped to NixOS probably a couple months ago, and NixOS is really great in my opinion for programming. And if you're wanting to learn something like DevOps, which is a pretty big subsection of programming, like if you're wanting to learn DevOps just generally, first off, the thing that you'd always have to do is, first you learn some sort of programming language, like Python, just something pretty high level, so you can understand the abstractions. Then after doing programming, then you have to learn things like Bash, and then after Bash, you have to learn something like Windows Shell and then after all of that, then you have to learn Jira, and then after all of Jira, then you have to learn, whatever thing it is that you're going to run for your compiler so that you can start doing it and start actually getting really decent error results from your compiler. And then after that, then there's a huge set of things to drop up to eventually where you can say, okay, I'm a DevOps engineer. I know a lot about DevOps. Whereas if you have NixOS, like if you're really used to using NixOS, using shell.nix files is pretty much all you need for DevOps. And for making like a sort of standard environment. You don't need like Docker containers, you don't need all this other stuff to wrap whatever it is you're doing. Because you define like whatever it is you're compiling in your Nix files. And so DevOps becomes like trivially simple, and all you really have to do is just ping a server and it knows, oh okay, I'm going to pull from GitHub and build, and then I'll email whoever it is, or whatever it is you're doing in your DevOps pipeline. You probably would have some sort of instant notification thing that would pop up. But there are faster routes if you exist in some sort of group that may or may not be generally thought of as whatever. But there are a couple things that I want to say if you're going to want to go through these for book recommendations. One is that it's like I've been programming for a while now. Like I've been programming probably since middle school, something like that. Whenever I got Arc, I had been using Ubuntu, I think, for like 2-3 years. I learned programming about a year before I started Ubuntu, something like that. So maybe 5th grade, 4th. I don't really remember. It's not really important. But I've had a lot of time to do programming. I also, of course, have like a CS degree, so I kind of just somewhere in here will have the assumption that you'll know something that is probably not obvious to you. Or maybe something will be obvious to you that wasn't obvious to me when I was learning this. Like, again, although I had learned programming for a lot of time, I hadn't really learned that much of design groups. Like, it's only really recently that I've started learning about functional programming in Haskell and things like that. Mostly I had been working on fairly low-level stuff, like template, or some whatever interested me at the time that I had seen in the languages that I was using. So like Python, a lot of the libraries that people would make for Python, or like C++, just random things like templates, of course, or like autos or lambdas or something like that. And then of course there's like Fortran procedural programming, which is very heavily that. But basically, I probably make some assumptions in here, somewhere that is not obvious and probably really strange. Like, for example, one of these things that I have in here as a note is I call things programming environments, and I know this is not how people use the term, because generally, whenever they talk about programming environments, they're talking about their IDE, like Eclipse or Visual Studio or something. But to me, because I'm so used to using like just standard text editors like Vim or Nano or something. Vim is not really standard, but the programming environment to me is whatever sets of functions are available to you at the time that are so ubiquitous that you can't escape them. So Unreal Engine is very heavily, actors, all this other stuff. If you're wanting to do anything in Unreal Engine, you're going to have to learn way more about Unreal Engine than whatever language it's in. I mean, it's only in C++, but but Unity, for an example, if you program in Unity, you're not really learning C#. You are learning Unity C#. And to me, those are so significantly different that I have to have a distinction between the two. My distinction is like programming environment. Like Google Test, I think I consider a programming environment because there's a ton of functionality in Google Test that is just hard to make. And then, of course, it's like programming suites or whatever, like Python, Matplotlib, or SciPy, or all these other stuff that are available in Python. All of that to me is the programming environment, and that's not how people talk about it, but that is how I call it internally. And so I end up saying stuff that confuses people. But I am very heavily been in programming, as well as having a lot of background in other things such as like math or physics or even linguistics. That to you it might be pretty hard, and there might need to be something as a sort of jump. So for an example, I have computer graphics, and if you're learning just computer graphics, you might be learning, the pipeline or something like that, and then I pretty easily jump from computer graphics to like shaders, or from computer graphics to real-time computer graphics, because to me the math is inconsequential. But to you, or to somebody who is not not math heavy, it probably isn't, and you'll probably need some time to really go through the math. Alternatively, for you, it might be really easy for you to jump between languages. Like you could probably really easily jump from C++ to like Haskell or something like that. For me, it's not. I tend to really try to learn a lot about the language, which is hard when you're front loading it because you don't know what questions to ask about the language until you've been in it for a while. Meanwhile, if you just treat some things as just like, oh, of course they have this, and don't, you can really quickly learn the main context of a language. Like for an example, I was trying to learn I can't remember. It was something, and it was just I was like at the Hello World stage. I wasn't even at the point where I could make decent applications, and I was trying to figure out templates because I figured that this would be a good time to learn templates. The second thing that I want to state is that this is very heavily biased. Of course, I mean I'm very heavily biased. I don't know that much about. Again, like I said I don't know that much about a lot of the newer stuff, like functional programming, let's say imperative programming, getting out of object-oriented programming. All of this is pretty recent to me. This wasn't something that I've been doing since middle school. Most of this, because most of the time whenever I'm doing a project, I tend to be very hyper-centric on that project. And so a lot of things will just be not known. So I don't think there's any UX UI in here. And that's just because I never really wrote UX UI. Pretty much everything I worked on had been like a simulation or something, similar to a simulation where you just kind of run it and then you get the results. So maybe like a prime function finder. Specifically what I worked on were fluid mechanics, some condensed matter stuff, maybe like nuclear physics simulations, things like that. So I mean, I'm very heavily biased towards the sort of things that older codes used to do, and not so much newer stuff. Like again, optionals. That's also pretty recent to me, or pretty recently learned for me. Trying to think of anything else. Folds, things like that. Way more functional programming. Like I don't even think I heard about Haskell. I knew Lisp. Funnily enough, but I didn't. But yeah, that's mostly what I wanted to say. If you're wanting to fork this repository, I guess I should show off where it is. Oof. GitHub. I am signed in. Learning Map Network. It's this one. The name is Peripatetic Neophyte Learning Map Network. If you want to fork it, if you want to branch it, and just populate it with whatever you want to populate, you can change it. You can change the tags. Well, actually, I sort of prefer that you didn't make too many changes to the tags. I sort of like how they are now, and if I try and bring your thing in, it might take a while because I'm looking at the tags. But yeah, I mean, the only thing that I really don't want you to change when you do this is I want the structure to be the same. Let me see if I can get one that doesn't have much in here. Right. I want it to be no context, and then if there's anything sectioned in it, what I wanted this originally to be was just no context and then with context. So if you wanted to learn OOP or something, and you already knew a lot about Java, you could just really quickly. Like the Java is OOP, so there's not anything to really specify. It's just that this would be kind of like, oh, this is what OOP is. You know, this is water. What you have lived in your world is OOP, and then by specializing it, you could then go, oh, by the way, functional programming exists, which is somewhere. I have no idea where it is. Structured, imperative, functional. Oh, it looks like functional is brought up from imperative. It's just the way it's sitting. Functional, again, is really easy to learn from Haskell, or if you know functional programming, Haskell is, of course, also pretty easy to get used to. But I had to create the sections in here because it was harder for me to think of imperative programming or something as a context to learn general programming, as opposed to just thinking of it as a section. Because again, there's two separate issues. One is that to be considered a physicist, there's a whole set of things that you have to learn before you can be considered a physicist. If you're wanting to, at the same time, there isn't really a good distinction between the two. Like there's not really a distinction between knowing the sort of cores of physics and at what point you jump from the core to be an E&M or something like that. But for the most part, it should be relatively simple to get into. I hope it's simple to get into. But yeah, this is it. Hopefully you can get some really good book recommendations from this. If not, I don't know. If not, then this is a failed project. That's basically it. Alright, see ya, I guess.